Sir, is it compulsory to give reason in every question?
Wait. Yeah. Okay. Right. Since there was lots of background noise, I'm just muting you all. Okay. So good evening, everyone. We will start today's class and we'll continue the topic, which is motion, right? Motion. Now, I hope all of you have basic idea about speed, right? Everyone, good evening, Jia. Everyone have basic idea about speed? Yes, right? What was speed? Speed is basically rate of change of distance. Rate of change of distance, right? Yes, correct. Then we talked about uniform speed, non-uniform speed, and average speed, right? And average speed. We discussed the concept of average speed also. Okay. Now, after speed, there's the one quantity. There's one quantity that we need to study, one physical quantity, right? Which is basically called as, okay. Now, before talking about that physical quantity, let us see this. We talked about uniform and non-uniform velocity, uniform and non-uniform speed, right? So I can say that speed can also change with respect to time. Yes or no? Tell me, can speed change with respect to time? Yes, obviously, right? For example, when you talk about non-uniform motion, in non-uniform motion, non-uniform, right, speed, the speed actually changes with respect to time, right? So what can we say about that physical quantity? So that physical quantity is called as acceleration. Okay, so there's a physical quantity called as acceleration. So acceleration is just like speed. Okay, when we talk about speed, speed was rate of change of distance, rate of change of distance. But when we talk about change in speed, change in speed, right? I'll just write one parameter which is also called as velocity. I will explain what is this velocity, right? With respect to time, with respect to time is your acceleration, or you can say, so it is rate of change of, because rate is always with respect to time, rate of change of, tell me, rate of change of speed or velocity. Okay, right? Okay. Now, your question should be, okay, sir, right? So why we are calculating acceleration, right? Because think about it now. Just think about a normal scenario. Suppose you are traveling, okay? You're traveling and you're traveling from, suppose, Vidyanagar, right? You're traveling from Vidyanagar and you're going to, suppose, Bangalore. Think about it. You're going to Vidyanagar, going to Bangalore from Vidyanagar. Okay. Now, will your speed, right? Will your speed, right? Yes. Accelerator is the basically device that helps us to do that. Okay. Right. So suppose when you're going from Vidyanagar to Bangalore, is your speed be same? Tell me. Your speed will be same or different? Tell me. Will your speed be same or different? Obviously it will be different, right? And sometimes it will be fast, sometimes it will be slow, sometimes you have to stop, right? Okay. Now, when you are actually going fast, you have to, or the speed is changing, right? Speed is increasing with respect to time, right? Anna? Yes. Okay. Now, when you are going to stop, when you are stopping, then the speed is decreasing, right? When you put brakes, the speed will decrease. Anna? So I can say in that case, in that scenario, the speed is changing with respect to time. Yes or no? Right? Or we call as, see, speed and velocity will be similar depending on the change, right? So why I'm writing velocity? Because when you talk about uh, distance, right? We also talked about displacement. Hi, Anna. We also talked about displacement, right? So what was speed? Speed was rate of change of distance. In the same way, rate of change of displacement is your velocity. So I'm not talking about velocity in detail because then we have to use the concept of vectors also. So that we are leaving for now. Okay, so I can say, sir, from Vidyanagar to Bangalore, the speed will keep on changing. Sometimes it will be more, sometimes it will be less, right? So I can say, or when you talk about this, right, what we do, we use accelerator, and if we need to go fast, we use accelerator, right? And if we want to be slow, we will use brakes. So what is changing? So speed is changing, right? And this change is called as acceleration. This change is called as acceleration. So I hope all of you understood what is acceleration. Acceleration is basically the change in speed or velocity with respect to time. Okay, now tell me, suppose when you started, right, when you started from Vidyanagar, your speed was u, okay, and when you reached and here you have a point B. So at point B, your speed is v, okay, and the time taken is t hours, right? So tell me, what would be the acceleration? Yes, rate of change of speed. What would be the acceleration? Tell me. Batao. When you talk about change, right? Change is always, you should remember, sir, change is always final minus initial. Yes or no? Yes or no? Tell me, right? Change is always final minus initial. No, Sandhya, not 1 unit, right? What is initial velocity? Write it down step by step, right? What is initial velocity or initial speed? Initial speed is equal to what? U. Very good. What is final speed at V point? At V point. V, correct, right? What is time taken is T. So I can say, sir, acceleration is equal to final speed minus initial speed by time taken. By time taken, yes or no? Yes or no? Tell me. Agree? Easy, right? Hi, Anna. So what is final? What is final? So final is V. What is initial? Is U by T. So this is the acceleration. Got it? This is the formula of basic definition of acceleration. Anyone have any doubt in acceleration? Raise your hand. Tell me. Yes, V minus U by T. So I can say, sir, how many parameters do you have here? Tell me how many, right? How many variables do we have here? Tell me how many variables? 4. Very good, Ananya. 4, right? 4, na Shrey? Sandhya, 4. We have A, which is acceleration. A, acceleration. When you talk about V, what is V? V is final velocity or final speed, right, guys? I'm using velocity because, right, we generally use both velocity and this speed, right? But since we are talking about straight line, okay, I'll tell you what is velocity, right? Okay, so final speed u is equal to initial speed and t is equal to time taken. Okay, now what is again, right? What is speed? Tell me. When you talk about speed, say speed was what? Speed was, right? Speed was what? Speed is distance. Speed is equal to rate of change of distance. Rate of change of distance. Of distance. Yes, correct. In the same way, velocity is basically rate of change of displacement. Change of displacement. Okay, right? So I didn't talk about velocity a lot because you might get confused, right? That's why I didn't talk about velocity first, right? But And there's also one thing that we are talking about, right? We're talking about only straight line motion. We're talking about straight line motion. Now, if you're talking about straight line motion in one direction only one direction, right? Now, if you talk about straight line motion in only one direction, is there any difference between speed and velocity? Tell me. Is there any difference between speed and velocity if you're talking about only one direction or straight line? Because in that case, right, distance and displacement would be same, yes or no, right? Distance will be equal to displacement. If you talk about straight line motion, think about it, right? If you're talking about straight line motion only in one direction, like this, okay, this distance and displacement would be same. That's why speed and velocity would be same, right? Okay, physically it would be same, okay, right? Okay, so that's why I'm taking, I'm saying sometimes speed, sometimes velocity, right? Because our syllabus is confined to straight line, okay, right? Our syllabus is confined to straight line. We will see what will happen if it is not in straight line, right? We will see those cases also. Okay, so anyone have any doubt in this case? Tell me, anyone have any doubt in this case? Okay, now this is according to your syllabus, right? But in reality, actually the formula of acceleration, right? So is, okay, so when you talk about higher classes, right? When you talk about higher classes, the formula of acceleration would be rate of change of velocity, change of velocity. Okay, yes, Jia, I'm repeating again, don't worry. So this is the general formula. Okay, I'm saying that when we talk about only in one direction, the speed and velocity will be same because distance and displacement will be same, right? The value of distance and displacement would be same, right? That's why we can say acceleration is rate of change of speed, right? Final speed minus initial speed. So there's a limitation. What limitation, sir? We are talking about only one directional motion, only motion in one direction. But if motion is not in one direction, then what would be the basic formula of acceleration? Tell me. Then what would be the basic formula of acceleration? What is the general formula of acceleration? If motion is not in one direction, then it will be rate of change of velocity. Then we will take velocity. समझ में आया? Tell me, हाँ या ना? Right? Now, what is the difference between velocity and speed? Right? Let us see. Difference between velocity and speed. Okay? I'm audible, guys. I'm audible, everyone. यहाँ तक सबको समझ में आ रहा है? Right? Okay, very good. So you might be asking, sir, what is the difference between velocity and speed? So let us see. Difference between speed and velocity. Speed and velocity. So if you understood the concept of displacement, right, you should answer this. Okay. For example, when you talk about speed, start with basic formula. Speed is what? Distance by time, change in distance by time, right? Whereas velocity is what? Very good, right? Correct. Velocity is displacement by time. Now, the basic difference is this distance and displacement only. What is distance? Distance is a scalar quantity or vector quantity. Tell me. Distance is a scalar quantity or vector quantity. Tell me. Yes, scalar quantity. Very good. Right? And what about this velocity? velocity. So distance is scalar quantity, your scalar quantity, which means it does not depend on direction. Does not depend on direction. What about displacement? Displacement is vector or scalar? Tell me. Displacement is vector. Yes, very good. Vector, correct. Displacement is vector. So velocity will also become vector. And it will depends on direction. It depends on direction. On direction. Okay. So let us see one case, right? Let us see one case. Okay. Let us take one case. This is, suppose, a circular path, right? This is a circular path. Okay. This is a circular path. A car starts from this point. A car starts from this point. Okay. Right. And after, this is concept check. Okay. So car started this point at t is equal to 0. Okay. The radius of this track is, suppose, 20 meter. The radius of this track is 20 meter. Okay. And at time t is equal to 60 seconds, right? Okay. The car reaches at this point. Okay. So first, what is this? What is distance? Question number A. What is distance covered? Question number B. What is displacement? Question number C. What is speed? Question number D. What is velocity? Right? Okay. Tell me. Step by step, everyone, step by step. From this point to this point, it is diametrically opposite point. And we know that, right? Circumference of circle is equal to 2 pi r. This total length is 2 pi r. And diameter, you know, diameter is equal to 2r. Right? Diameter is equal to 2r. This is something that we know, right? Tell me, A, B, C, D, answer. Very good, Aditya. Displacement correct. Okay, you don't have to calculate for pi, just keep pi as it is, right? You can just write pi as it is. So yes, very good, I'm getting answers. So let us see solution. Very good. So A is distance. Now the total length is 2 pi r. So what is the half length? Tell me. If total length is 2 pi r, what is the half length? Half length would be pi r. Yes or no? Tell me. Yes or no? Right? Which is equal to 20 pi. So distance is equal to 20 pi. Now, if you find the value of pi, so it is 3 point, right, into 3.14, right? So it would be what? It would be around approx. I'll just take approx, right? Approx 60 meter or 62 something meter, right? 62 meter, right? 62, 63 meter. Okay, right? This is a distance. Now B, very good, displacement. Is 2r, which is very good, 40 meter, correct. Now tell me, what is the speed? Speed kya hoga? What is speed? Speed is equal to what? So I'll consider it as 60 only. Okay, I'll just take approx and I'll calculate 60 only, right? I'll write 60 only. Okay, approximately. Okay, so just simpler calculation. Tell me, what would be the speed? The value of pi is equal to 22 by 7. Pi is equal to 22 by 7, which is almost equal to what? 3.14 now. Tell me, right? Pi is equal to 22 by 7, which is almost equal to 3.14. Okay, this is the value of pi. Okay, what is the speed? Tell me, speed will be distance by time. Yes, very good. So distance I will approximately take as 60. Time is what? 60 seconds, right? Time is 60 seconds. So 60 by 60. So it will be what? Tell me. It will be what? 1 meter per second. Now, meter per second, right? 1 meter per second. 60 by 60 is 1. Now, how come it will be 0? It is not 60 minus 60. It is 60 divided by 60. Right? And what is velocity? Tell me, what is velocity? Yes, correct. So it is 40 by 60. It is 2 by 3 meter per second. Correct? Now, I hope all of you understood this concept. Tell me, all of you understood this concept? Right? Nabil, you joined late, right? You joined late, na? You joined now? Okay. So I'll solve one more concept check and I'll revise the concepts again after that concept check, right? So let us see one more concept check. Okay. Yes, yes, I will upload the recording. Don't worry. Concept check. Guys, it is a request. Please join on time because, right, you will miss, if you miss even first 10-15 minutes, you will miss a concept. Now, the question is this, right? Step by step. The question is this. So suppose you're moving like this. Okay. And this. Okay. Now, this is your 8 kilometer and this is 6 kilometer. Okay, this is 8 kilometer, this is 6 kilometer, right? Okay. Yeah, I'll explain, don't worry. This is point A, initial point. This is point B, final point. So time taken from A to B, from A to B, right, is equal to 2 hours. 2 hours. Okay. So find question number A, distance, B, displacement, C, speed, D, velocity. Okay, now it starts from rest, right? It starts from rest. Start from rest. Rest, right? So find acceleration also. Okay? Step by step, everyone, step by step. Yes, yes, obviously, Sinchana, you have to use Pythagoras theorem. No, Aditya. Wrong, Aditya. Okay. You just have to calculate. You calculated wrong, Aditya. You added wrong. Addition is wrong, right? Don't be hasty. Take your time, step by step. Yes, correct now. Yes, correct, Tanushri. Correct, correct, Ananya. Step by step, everyone calculate. Yes, correct, right? Very good. No, Sinchana? No. So let us see solution. So what is distance? Distance is quite easy. Distance is total path length. Distance is total path length, which is A to this point is C, right? And then C to B, which is AC plus CB, which is 8 plus 6, 14. So distance is equal to 8 plus 6, which is 14 kilometer, right? Yes. Now, when we talk about displacement, so displacement is always what? Shortest, initial to final, shortest path, right? Which is this, right? So to become right angle triangle, and this will become your hypotenuse, right? So this will be your displacement. AB will be displacement. So displacement will be what? It will be AB, AB. And we know that AB is hypotenuse, right? So okay, guys, just wait. Yeah, I was disconnected. Yeah. So hypotenuse square is equal to base square plus perpendicular square, which is hypotenuse is equal to whole under root, right? Base square plus perpendicular square, right? Yes, correct. Very good. So h is equal to what? H square is equal to 6 square plus 8 square. So h square is equal to 64 plus 36, which is equal to 100, which is equal to 10 square, right? Yes, 10 square. H square is equal to 10 square. H is equal to 10. So AB is equal to 10. Is equal to 10 kilometer. So displacement is 10 kilometer. Yes or no? 10 square, 100 is equal to 10 square. Now, so displacement is 10. How come it will be 5? Right? Okay. Now, what is speed? What is speed? Speed is equal to distance by time. Right? So distance is 14 by time is 2 is equal to, yes. Tanushri, what is 8 square? Tanushri, 8 square का value क्या होता है Tanushri? 8 square is equal to 64. Na? 8 into 8 is 64, right? And 6 into 6 is 36. Got it, Tanushri? Right? Nabil, you are getting this? Tell me, Nabil. ये समझ में आ रहा है? यहाँ तक सबको समझ में आया? So 7 kilometer per hour. Now, when you talk about velocity, right? Velocity is rate of change of displacement. Okay, right? Velocity is rate of change of displacement. That is displacement per unit time. Displacement by time. Displacement is 10, time is 2. So it is 5 kilometer per hour. Velocity is 5 kilometer per hour. See, now tell me, your total path, is it a straight line? Tell me, is it in only one direction? Tell me, is this whole path is one direction? Is it just a straight line? No, na. From A to C, it is straight line, but from C to B, the direction is changed. That's why distance and displacement are not same. Distance and displacement are not same, right? Now, when you talk about acceleration, so acceleration is rate of change of velocity. Tell me, what is final velocity at point B? At point B, what is the final velocity? Tell me. B पे velocity कितना है? We just calculated. It is what? Tell me. 5. Correct. Velocity, Sinchana, velocity. I calculated enough velocity. Final velocity is 5. Very good. What is the initial velocity? Tell me. Initial velocity कितना हो गया? 0. Starts from rest, right? Rest से start होता है 0, है ना? Right? 0. By time is 2. So it is what? Yes, correct. 2.5 kilometer per hour square, because it is kilometer per hour by hour, kilometer per hour square. Right? Anyone have any doubt on this? Tell me. Raise your hand. Anyone have any doubt in this? No? Clear? Nabil, you're getting this concept? Okay, chalo. So this concept is clear. So next concept, okay. So I guess acceleration is clear, right? We will solve various problems, simple problems today. Yes, Kartikeya, I'll explain. Don't worry. So let us see, right? I'll explain another concept. You will get that concept, okay? From there, okay? Right? Yes, Nabil, because you joined late, right? That's why. Okay, I'll explain once again. So what is acceleration? Sir, acceleration is basically rate of change of velocity. Velocity कैसे change कर रहा है? It is rate of change of velocity. Now, see, if you're starting from rest, right? Think about it, right? If you're starting from rest, your initial velocity will be 0, na? And it is given in the question. Only it is given, right? That starting at rest, it means your initial velocity is 0. Okay, right? Okay, so I'll just write again acceleration. So what is acceleration? Acceleration is equal to final velocity minus initial velocity by time taken. Okay, by time taken. Now, what is the meaning of this, right? Means if this change, right? If velocity is not changing, right? If final velocity and initial velocity are same, if velocity is not changing, right? Then that is, tell me, in that case, what would be the acceleration? Tell me. If final velocity will be equal to initial velocity, tell me, Jia, Nabil, tell me, if final velocity will be equal to initial velocity, in that case, what would be the acceleration? Tell me. Yes, very good, Nabil, very good, Anya. Jia, you are getting this, Jia? Shreya, correct. Yes, it will be what? 0, right? A will be 0, acceleration will be 0. Now think about it, right? It makes sense, now, right? If you're moving with same speed, same velocity, do you need to use accelerator? Tell me, do you need to use accelerator? Akash, you joined very late. Right, Akash? You might not get today's class because first 30 minutes is very important. Okay. Now, tell me. Okay, this is one thing. Now, what is the meaning of uniform speed? Tell me, what is the meaning of uniform speed, guys? I hope all of you remember. What is the meaning of uniform speed? Tell me, uniform speed क्या होता है? Same distance, right? Same distance in same interval of time. Yes or no? Right? Right? Moving with same speed. Very good. In the same way, don't you think that there would be the concept of uniform acceleration? Yes or no? Right? Right? What would be the uniform acceleration? Uniform acceleration means, right, same change, right? Okay, same distance. Again, it's not distance now. In the acceleration, the thing that is changing is velocity, right? So it will be same or equal, right? Instead of same, I would write equal. Equal change in velocity or here I'm just talking about speed, right? Okay, or I'll just write equal change in speed only. Okay. To be it simple, to make it simple, I'll just write equal change in speed in equal interval of time, equal interval of time. Okay, equal interval of time. Interval of time, right? Yes, correct. In same direction. In same direction. Okay, so you're getting this, right? Yes or no? Everyone have any doubt in this? In the case of uniform speed, we say equal distance in equal interval of time. Here I'm saying equal change in speed in equal interval of time, right? For example, let us see one example. Let us see one example. Okay, so suppose I'm having this time and this is your speed, right? This is your speed. So I'll just write as u. So when it was 0, it was also 0. When it is 1 second, it is 2 meter per second. It is in meter per second. And this is in second. When you talk about 2 seconds, it will become 4 meter per second. When you talk about 3 meter per second, it becomes 6 meter per second. When you talk about 4 seconds, it becomes 8 meter per second. Now tell me, what is the change between 0 to 1? What is the change between 0 to 1? What is the change in speed? Tell me. From 0 to 1 second, what's the change in speed? Right? 2. Yes. What is the change between 2 to 4? What is the change between 1 to 2 seconds? This is also 2. Very good. Yes, Nabil, I will send the recording. Don't worry. Right? Try to understand whatever you can. We will play Kahoot also. What is the change between 3 to 2? What is the change between 3 to 2? Again, same 2. So don't you think that, sir, in this case, the change between equal time intervals, the change between every 1 second is same. So this is a case of uniform acceleration, non-uniform acceleration. If it is in same direction, I'm talking about speed, that's why. Right? Is it a case of uniform, non-uniform? Yes, correct, uniform, right? So this is example of uniform. Okay, now let us make a graph, right? Let us try to make a graph. Okay, let us plot this in a graph. I hope all of you remember the graph of distance time. So here, tell me, x-axis should be what? X-axis should be what? Time? Yes or no? X-axis should be time. So this is time. And this y-axis should be what? Tell me. ये क्या होगा? Y-axis क्या होगा? But distance नहीं यहाँ पे नहीं, speed है ना? समझा? Distance नहीं है, speed है, right? Yes, it will be speed. Speed, right? Speed. Got it? है ना? Right? So this is called a speed time graph. It is called a speed time graph. है ना? Right? So let us see this. It is 0, 1, 2, 3, 4, 5. And this is, tell me, 2, 4, 6, 8. Now, can you put the point? Can you put the point? Tell me, Sandhya Jiya, can you put the point over here? 0, 0, this point. Right? 1, 2, 1, 2, this point. 2, 4, 2, 4, this point. 3, 6, this point. 5, 8, right? In this point. Okay. Now, don't you think, sir, it will be a straight line? It will be a straight line, yes or no? Right? Right? But is it same? Tell me, is it same as the straight line of this displacement time graph? Tell me, is it same as the straight line of displacement time graph? Right? No, it is not same, sir, because when you talk about displacement time graph, when you talk about displacement time graph, that is the change of distance or displacement with respect to time. But here we are changing what? We are changing speed or velocity with respect to time. Okay? So here it was distance or displacement with respect to time. So this change, right? This straight line represents uniform speed. But here in this case, in the second case, it is change in speed with respect to time. So it will represent uniform acceleration. Okay, right? So what about if the graph is not straight line, then if the graph is not a straight line, then tell me, if the graph is not a straight line, suppose it is like this. It is like this. This is time, this is speed, right? Speed. Then this is a case of uniform, non-uniform. Non-uniform speed nahi, acceleration. Again, remember, this is uniform and non-uniform acceleration, not speed, guys, not speed. This is acceleration, not speed. Do not get confused. This is uniform acceleration. Don't worry, we'll play lots of out. All the concept will be cleared, right? This is uniform acceleration. Very good, Gia. This is non-uniform acceleration. Right? So I can say very good. So I can say it's a non-uniform acceleration. Acceleration means, right, unequal change in speed, unequal change in velocity, or speed, right, in equal interval of time. Equal time. Okay, right? So I guess this is clear. This is clear. Okay, guys. So I guess you understood the concept of acceleration, hai na? Now, uniform acceleration. Uniform acceleration. If you talk about uniform acceleration, what would be the speed? Speed will be uniform or non-uniform. If an object is in uniform acceleration, then its speed would be uniform or non-uniform. Think about it, guys. Think about it. That is the concept. The speed will be changing. हाँ या ना? Think about it ना. यहाँ पे speed क्या है? Same है कि change कर रहा है? Tell me. That is the concept, right? Think about it. यहाँ पे speed क्या है? Change कर रहा है कि same है? What is the speed? Very good, Kartikeya. Correct, Kartikeya. The speed is changing, right? The speed is changing. The change is constant, but speed is changing, right? So the speed is changing, then it is uniform motion or non-uniform motion? Tell me. If the speed was changing, right, it was uniform or non-uniform? It was non-uniform, na, right? Got it? Yes. So I can write uniform acceleration right is also your changing velocity, changing speed of velocity, right? है ना? Change करेगा, right? But equally change करेगा, right? It will change equally, but it will change. So it will be non-uniform speed. Okay, right? Okay, okay, guys. So I guess this concept is clear. So this is more or less the end of our chapter, right? Let us see some concept test. We'll play we will try to play 4 concept tests.